Hello Rustaceans, welcome to a new video of this Rust series. So today we will build our own AI powered application and we will also explore and learn different concepts related to AI like NLP, deep learning, machine learning, NLG, NLU, and there are a lot of concepts to learn. So I'll try to keep them simple, I'll try to keep them concise, and it will help you understand in a better way. I will share you the examples of all the concepts. So before moving forward with today's video and the implementation of the LLM, let's just have a recap of our previous video. We have built a multi-threaded web server in our previous video. We have explored the concept of TCP, HTTP, sockets. We have also learned about sockets, how to implement the thread pool. We have started with the implementation of single-threaded web server, and then we have added a feature of multi-threaded web server, multi-threaded. So we have implemented the thread pools into that web server. So I hope you have learned all these basic concepts and the bare bones and backbones of Rust, the concepts of ownership, or you can say the counter references and so on and so forth. So I hope you have hands-on on these concepts. So let's just move on to the next. Let me just switch the screen. Yeah, we are on to the. So I have added the definitions of all these concepts here, and I'll try to share the examples and will explain it to you. So let's just start with the first concept. AI, artificial intelligence, means the simulation of human intelligence. So let's say how machine has been or you can say the simulation of the human intelligence into machine. So AI is the science and engineering of creating intelligent machines that can simulate human intelligence. Machine can simulate human intelligence. Let's say uh, if you have ever seen the or you have noticed that if you add some kind of products or you have searched a specific product on an e-commerce platform, so you will see the next time you will be displayed the recommended products similar to that specific search on or the clicks. So the e-commerce platforms or any of the platform like Netflix, you can consider the examples of web series videos. So how these platforms suggest you the specific items, so based on your interests and so on and so forth, so they are simulating the intelligence. So they are the machines decide uh, what is the interest of that specific human, and then based on your interests the products, the movies, web series will be shown to you. So this includes learning, reasoning, problem solving, perception, and using language. So you can consider an example of Tesla as well. Um, Tesla decides where to brake, where to race, accelerate, and so on and so forth. So you can consider the autopilot mode of the Tesla. Now, NLP, natural language processing, means processing of your natural language. If you go on to the ChatGPT, you will write some kind of prompt into your native language or natural language like English, Hindi, Urdu, whatever, and then the machine will process your natural language. This is the first step, and there are other steps like NLG and NLU first. And natural language understanding means machine will understand what human tries to ask or what human is asking. And then the next process is NLG, natural language generation, means machine will generate the response into your language. Let's say if you have prompted machine like in English language, the machine will generate the response in same language in let's say English. So NLP, a subfield of AI focused on enabling computers to understand, interpret, and generate human language, text, and speech in a valuable way. NLU, this is the input or comprehension part of NLP. NLU focuses on a machine's ability to read text and figure out its meaning, including the intent, entities, and sentiment. So let's say an example would be, uh, if I want to ask ChatGPT, hey ChatGPT, generate or create a treasure hunt game. So how machine will get to know, or ChatGPT will get to know that uh, for which specific field I have to create the treasure hunt game. So let's say whether it should be related to engineering, whether it should be related to any cricketing entertainment purposes, and so on and so forth. So how machine will analyze the sentiment, the intent of that specific prompt, this is a separate stage. So here you can see an example. This is the compilation stage where you will see lexical analysis, syntactic analysis, semantic analysis. Means the input will be passed to the lexical analysis, lexical analyzer, which means your language will be converted or transformed into tokens and then lexemes and so on and so forth. So tokens, so this is a lot of there are a lot of different concepts in here, so I don't want to get deep dive into these complex concepts right now. So I'm trying to keep it simple for now, so because we have to focus on the integration of LLM and we have to build the AI powered application, so we will have to build that. So NLG, the generation step, natural language generation. This is the output or speaking part of NLP. NLP focuses on constructing natural human-like language from structured data. You can consider an example of Google Translator, Alexa, Siri, and so on. LLM, large language models. An LLM is a massive deep learning model trained on vast quantities of text data. Its fundamental ability is to predict the next word in a sequence, which enables it to perform sophisticated NLU and NLG tasks. So let's say there are a lot of LLMs, ChatGPT, OpenAI, sorry, Claude. So each of these platforms have different models. So let's say OpenAI has GPT-4o, Claude has Opus, Sonnet, and so on and so forth. Now, Gen AI, generative AI means this is a category of AI that focuses on creating new original content rather than just analyzing or classifying existing data. It can generate text, images, music, code, and more. You can consider an example of DALI, Gemini's Nano Banana. So it generates the image. So let's say if I want to generate an generate a thumbnail for my YouTube video, I can ask for it. I will pass the, let's say, description, title, whatever content I want to display on my thumbnail. I will just pass it into my natural language and it will convert it into the generation steps, understanding and generation step, and it will generate an image or thumbnail for me. Machine learning, this is the engine that powers most modern AI. It's a subfield of AI where systems learn from data to identify patterns and make decisions without being explicitly programmed for every task. So automatically generate, uh, let's say, uh, machine will learn from the past data or the conversation. So let's say if so I have created a new account on ChatGPT, and then I'm asking that, hey ChatGPT, write a cover letter for me. So the ChatGPT will generate a generic cover letter for me. And in comparison with that, if I have existing account on ChatGPT and I have previous conversations with ChatGPT, I have the ChatGPT has some kind of data of mine in his, let's say, memory. So the response will much finer because it has already been trained on my previous chats. So ChatGPT knows the context of my, let's say, uh, myself and so on and so forth, about where I have worked, how many educations I have taken, and so on and so forth. So there is the difference between this concept. Deep learning, a subfield of machine learning that uses complex, multi-layered neural networks inspired by human brain to learn from vast amounts of data. It's a subfield of machine learning. Neural networks is a separate concept, like we have to implement weights, and this is a separate concept to explain, so I'm not getting deep dive into that specific concept. So there are a lot of concepts, or let's say agentic AI, multi-model AI. So I'm not getting deep dive into all these concepts, so I just wanted to share the basic uh, concepts that will be used along the way. So let's start with the integration of our AI application, or the LLM. So let me just quickly switch the screens. All right, so I have created a new project with command cargo new, and then let's just install create cargo. But before before adding any create, let me just explain. So I have already told you what the LLMs are. Let me just switch the screen. Yes, what LLMs are. Like, there are a lot of. Uh, so first of all, let's understand the open source model and the closed source model. So let's say we have open source models like DeepSeek, Quinn, and there are a lot of open source model that we can run locally into our directly into our machine and from our machine. And there are different models that we have to consume their APIs, like OpenAI's different models of OpenAI, Claude, Anthropic, let's say. So we have to consume their API, and then we will have to pay as per usage. So for now, what I will do, I will use the Gemini's API to help you understand how we can integrate uh, the LLM into our with the Rust language. So if we get hands on onto these concepts, as well as we will also explore these grades. So in our next video, we will get deep dive into how we can use uh, the LLMs directly from our machine, or local from our local machine. So let's just explore this rig. So there are a lot of grades like rig. There is Kalosm. Uh, there is Rustformers LLM. It is archived right now, but you can use the previous versions of this LLM. We have Llama CPP. So you can use any of the. If you want a specific grade for any specific LLM like Gemini, for if you want to integrate Gemini, you can directly use Gemini Rust. It's that behind the scene, all of these are using the APIs of the LLM, let's say Gemini. So right now I'm using the rig because its documentation is pretty much clear, easy to integrate or work with. So let me just click on the add the cargo add, switch the screen, cargo add rig and core. Let's just install the rig core, and then let me just go back to the documentation here. Let me just quickly get it here. Perfect. So now, um, let's just open the documentation here. So we have Rig is a Rust library for building LLM powered applications that focuses on ergonomics and modularity. So you can see an example here. It's showing the integration with OpenAI. So let's say OpenAI is equals to OpenAI client from ENV means get the OpenAI API key from ENV. So because we will use Gemini, so let's just get the API key of Gemini. So let me just search for Gemini Gemini API key. And then get a Gemini API key. We will be redirected to the Gemini's website, ai.google.dev/Gemini-API. Oops. Google AI Studio. right here, and I want to create an API key. So you can click on this create API key and then name your API key, let's say YouTube Rust. Because I have already created an API key, so I won't be creating a newer one. You can create a new API key if you haven't. So you can create a new project or import a project. So if you have different projects, uh, right here, I have multiple projects on GCP, so you can directly use from this drop down, or you can create a new project from here. So I'm not creating an API key, so you can create your own API key. I'm just adding the API key into my .env file. You can come here and you can add a .env file here, and you can add the, let's say, Gemini underscore API underscore key and your API key here. So there is another way you can, let's say, if you want to add API key directly, so you can create export and you can add the env here directly. Let's say Gemini export Gemini API key, and then you can pass the API key. So instead, I will directly pass the API key into my .env file, and I'll explain you how you can use that specific API key. So you have to install the .env package. So let's just go back to the documentation here. You can see GPT-4 OpenAI client dot agent, and you will have to pass the model. So GPT-4, GPT-4o, whatever model you want to use, dot build, GPT-4 dot prompt, and you will have to pass the prompt here, and then dot await, expect, and then the println, and it will respond you directly. So let me just quickly all right, let's just add a cargo add dot env, install the dot env, and let's just go back to the documentation to explore what we have inside our documentation of the rigs documentation. So let's say we have integrations. Inside integration, we have different modules, like say agent to CLI chatbot, and inside the CLI chatbot. However, if you want different examples of the, let's say, LLM integration, you can come here. The rig has a vast guide of, or great guide of integrations, and the, so let's say rig a Rust library for LLM powered applications and so on and so forth. So there are a lot of guides here. So CLI chatbot, you can use the CLI chatbot function here directly from here. So let me just go back to the rig's main documentation, and here I have the, so let's say simple example here. We have simple example here, and then core concepts. Inside the core concepts, we have rig provides a consistent API for working with LLMs and embeddings, and each provider like OpenAI Cohere has a client struct that can be used like completion model and embedding model. So let me just open the completion model, what we have inside the completion model. So inside the completion model, this is a trait completion model, and inside that we have response, mean a function completion, and the provider methods like completion requests. So I have opened the GitHub repository of the rig. So inside that documentation, we have the implementation of Gemini LLM. So let's say I want to integrate Gemini into my web application or any of the application or with Rust. How you can use that? You can pass the API based URL. They have implemented that already. You just have to consume their methods. So let's say what we have inside the build method, they are in default headers dot insert. They are adding the content type, the application JSON, adding the client. Let's say client struct has base URL, API key, default headers, and the HTTP client, and it will get the response directly from the Gemini. Because if you want to directly uh, get the response from API, you can do that, or you can directly consume the Rig's create directly. So Rig provides a comprehensive integration functions, so you can directly use that. So let's just go back to the documentation here and the code here. And now let me just remove everything from here and then dot env, import the dot env, dot OK. All right, so I have imported the dot env, and let me just go back to the documentation, no, learn reg documentation API official examples, and inside that official examples, what we have, ta-ta, inside that example, we have agent with grok, we have, let me just search for Gemini, search for Gemini here, Gemini agent.rs. Let's just click on this URL. It's taking a bit longer. All right, we have an example here how we can integrate Gemini API. So here, first of all, you have to integrate this tracing subscriber. What we it will do, it will help you debug easily. So you have to add the tracings. So let's say let's integrate the initialize the Gemini client. So client is equals to Gemini client and from env. So let me just quickly copy this code so that we can quickly test this and we will understand what we have it. So let's just quickly save it and let me just bring the API key here. Right, let's just install the crates that should be installed. So because right here you can see tracing isn't installed yet, so we have to install the tracing subscriber. Tracing is used for logging purposes. Let's say you can output the logs into your terminal or wherever you want it, because print and tracing have some differentiation between them. So let's say, let me just install everything inside that. Let's just quickly open the terminal. Let's just cargo, run the command cargo add. You can install, let's say, anyhow, that is, you can see anyhow here. Let me just show you. Here you can see the return error, anyhow an error, and then you can install the tracing subscriber, as well as we have to install the Tokyo runtime, and you can install the SERDI JSON, and installing all these packages, or you can say the crates. So here you can see we have initialized the Gemini client here, and then what this generation config here, because on the, let me just go back to the documentation. Here we are. So inside this documentation, mhm. Here you can you can see there is no any configuration setup here. You are directly initializing the OpenAI client and you are passing the agent here. Instead, we are passing the generate config struct here. Inside that, are passing top K and top P. What are these fields? So top K means so top K means the LLM has vast uh, different synonyms of different methods. Let's say, let's consider LLM want to use a word, or let's consider an example. Let me just go back to the document. So let's say Um, uh, so let's consider that AI wants to complete the sentence like the sky is whatever word should be used after that. So there are a lot of choices LLM has. So um, from the thousands of multiple possibilities, LLM has to choose top K means, let me just open, where is it? Oh, here you can see top K1 means it will uh, select from thousands of words. It will select one word from the, let's say if I pass the five, so from multiple possibilities it will get top five best possible selections or the options, and then from these five options, LLM will get the most better option for your next word. Let's say the sky is blue, or the sky is, let's say, full of clouds. Whatever words needs to be filled up next, so it will be selected based on the context passed to the LLM. So top K, top P is similar. There is a slightly different concept between them. Candidate count, and then you can pass all the default fields directly with default values. So now CFG additional parameters default with config, and inside that with config method we have passed the configuration, and we have passed agent. We have client dot agent. You can pass any of the model here. So we will directly use, let's say, let me just open the Gemini's website where we are. Okay, let's just get it here. Gemini, let's say models list. So there are a lot of options here. You can find it. There are free models as well as the paid ones. So let me just open the models. So inside the Gemini models, we have Gemini 2.5 Pro to 2.5 Flash. So we will be using the Gemini 2.5 Flash. Here you can see Gemini 2.5 Flash, Gemini 2.5 Flashlight. Both will work fine. Let me just open the documentation here. So you can directly use the Gemini from Gemini's completion. Gemini, and here you can see 2.5, 1.5 Pro, 2.0, 2.5 Pro, and so on and so forth. So you can use any of the model you want. So let's say I'm using the 2.0 flashlight, I can use it. So here you can see permeable means a context passed to the uh, agent or the model, and the temperature and the generate configuration has been passed. Tracing info means logs prompting the agent response, agent dot prompt how much would. So let's just run this code, and we will add a, let's say, feature of getting the input from user, looping over that inputs. So let's say cargo new, oh sorry, cargo cargo run. It's building the project, compiling, building. All right, so I have an error here. Main function is not allowed to be async. So what does this means? So I have to implement the all right, features. I haven't implemented the features. So let's just version is equals to whatever version is, and then features will be full. So means I can use any of the macros I want from the Tokyo. So I can, it will, so here you can see it will consume the Tokyo main from here and inherit that. So this main function will become an async function by using the Tokyo main. So let's just quickly skip the formatting. So save it really quick and rerun the command cargo run. Let's just quickly save it, rerun the command cargo run, and then what we have it here. It's compiling, and All right, so I am getting an error. Gemini API key not present. So let me just see what happens. Okay, so where is .env? I have .env and .env.ok. And let's just run the command. Okay, cargo, cargo run and rerun the command. So that not a function. Let's just import .env, save it and rerun the command cargo run. So I hope it will run now. Ta-ta-da. Waiting for file lock, shared package. Okay, so all right, here you can see the logs, debug logs, the tracing chat, Gemini AI operation.name chat, Gen AI system instruction be creative and concise and import and so on and so forth. This is the whole JSON, Gemini API content parts, the text, tool config and so on and so forth, and then info response okay, and then the Gemini responded I would chuck as much wood as a woodchuck could chuck. So let's say if I want to um, get the input from user, so let user underscore input is equals to, let's say, string new, and let's say let's make it mutable so we can update that, and std io std in dot read line, and inside that we can pass user as an input, and we can add the expect method here, field to read, let's say line, pass this user input here in prompt. Let's just rerun the command cargo run. So mhm. All right, so info prompting the agent. So let me just ask, let's say, build a treasure hunt game for an NJ, Rust engineer. Here you can see a response from the Gemini. Objective: find the rusty gem, specific file or directory. Clue 1, clue 2, clue 3, clue 4, and the final clue. Start with the Rust project. Engineer must use their knowledge of Rust file systems and version control and so on. So this is the response from Gemini. So what if I want to loop over the response? So it should not exit after the one input and the response. So what I can do, I can add a loop. So let's say loop, and inside that loop we can pass cargo run. And one more thing, the result should be there. Save it. An unreachable expression because we are looping over the code, and OK will not run until the programming executed successfully. But sorry, exited successfully. Now let's say uh, hello. Let's say hello, and thread is panicked. So unable to install global subscriber, set a global subscription error. So so there is an error here. We have to initialize it globally instead of, and then the client would also be initialized globally. So I don't have to reinitialize every time. The config should be fine. This is also fine. This is perfectly fine. Let's just move it here outside the loop and then prompting the agent. It should be repeatedly called. Let's just save it and rerun the command. Okay, so video is, yeah, it's not. Let me just, all right. So let's say, hello, Gemini responded, hello, how can I help you? So let's say, what is Gemini? Let's say Gemini is a family of large language models, LLMs, developed by Google AI. And it's repeatedly asking me to pass the prompt. If I don't want to pass, I should add the, let's say, a match expression here. So if I will pass exit, I will write exit. It should not pass the exit statement or input to LLM. Instead, it should exit the loop. You can implement different methods here, different you can perform different creativity here. So this is pretty much it from this thing. If you Let's just move on to the exploration of this RIC documentation. What we can do with RIC, we have the implementations of different agents. If you want to integrate, let's say, OpenAI, if you want to integrate Claude, you can integrate that. As well as if you want to integrate Redis, MongoDB, any vector database, you can integrate them as well using RIG. So let me just go back and let's just scroll down a bit and vector stores. And here you can see RIG provides a common interface for working with vector stores and indexes. Specifically, the library provides vector store and vector store agents trade, which can be implemented to define vector stores and indices respectively. Those can be then be used as the knowledge base for RAG agent or as a source of context documents. So there are a lot of stuff to explore right here. So if you want to explore tools, what we can explore. So here we have tool set builder. So let's say you build a RAG system, you can find the RAG system. RAG means retrieval augmentation, or you can say augmented generation. So you can a comprehensive guide to building an LLM application with RAG. You can implement that. So it means retrieve, augment, and then generate. So let's say if I want to, you can also implement the agent toolings like so you can, let's say, enhance the user prompt through LLM and then pass the enhanced version to LLM. So you can implement the chainings like that, tool chains. So this is how you can implement that. You can use Gemini REST directly to implement the Gemini, or you can use the Kalosm. So we have the simple LLM Llama New means Llama New will use the local LLM directly. So you can download the LLMs directly from Hugging Face, or you can use the Kalosm. It will use the Llama New. It will use the default Llama model, I guess 13B model. So, Rustformers. So, archival notice that they have archived that, but they have provided all the alternatives to integrate this. So, let's say LLM client, ALLMs, Llama CPP, Candle, Mistral, SRS, Kalosm, Candle Transformers, CALLM, and so on and so forth. So there are a lot of alternative solutions if you want to implement that. So this is pretty much it from today's video. I hope you have learned a lot of stuff from today's video. You got to know about different concepts of AI related concepts. So from our next video, I'll start the blockchain series. So and side by side I will upload the videos related to the systems programming. So I will continue both of these tracks in parallel. And then in the blockchain, we will start with the basics of blockchain, like what are the different concepts of blockchain, and then we will move on to the implementation of Solana blockchain. We will also explore Solidity, EVM, what EVM is, and so on, so forth. So there are a lot to explore in Web3 or blockchain. So this is pretty much it. I hope you have learned a lot of stuff from this video. If you have any queries, any feedback, you can reach out to me directly through YouTube's comment box, or you can directly reach out to me on my socials. This is pretty much it. I Be safe, be productive. So see you in our next video. Till then, bye.